Last time we introduced the idea of an antiderivative, or antiderivative if you prefer. In other words, an indefinite integral. And we did some fundamental examples. And you had a couple homework problems where you had to work through these things. Let's do another example, somewhat similar to your homework problems. Let's say we want to find the indefinite integral of x squared plus 5 over x squared. Well, let's put an extra 4 in here just for fun. It is a property of indefinite integrals, just like derivatives, you can do it piece by piece effectively. It's a linearity property that came out in the examples you studied. I could do this. I could split the integral of this sum into the sum of two separate integrals, and the constants, the 4 and the 5, could be brought out in front like this. And then, don't forget your dx. With this integral, 1 over x squared is the same as x to the negative 2 power. Again, the dx just tells you effectively what the variable is. That's the most basic way to think about it. There are other fancier ways to think about it, but it's simplest to just say that dx, just like with derivatives, is telling me that the variable is x, which matters if you've got more than one independent variable, like with multivariable calculus. Now go on and do each integral piece by piece using that reverse of the power rule. You know, with the power rule for derivatives, you bring down the power, subtract 1 from it. You do essentially the reverse for integration. Add 1 to the exponent and divide by that number. The exponent's 2 here, so I add 1 to it. I get a 3 and divide by that same number, 3. If you're unsure, you can always double check it in your mind. Take the derivative of 1/3 x cubed. The 3 would come down in front. 3 times 1/3 is 1. Subtract 1 from that exponent, I get a 2. 1 times x to the second power is x to the second power. It does work. And yeah, the 4 stays there because there's a 4 there. The derivative of 4/3 x cubed is indeed 4x squared. Once again, the 3 and the 1/3 would cancel. It's a little trickier with negative exponents. When you add 1 to negative 2, you don't get negative 3. You get negative 1. Negative 2 plus 1 is negative 1. Then don't forget you add your c. So in perhaps the most simple form, the final answer is 4/3 x cubed minus, well, I can write this as a fraction, 5 over x plus c. There's no logarithms here. Yes, it is true that the indefinite integral of 1 over x dx is natural log of x plus c if you thought of x as being positive. If you allowed x to be negative, you want to allow an absolute value sign in there, plus c. But even though we've got an x squared in the bottom of this fraction there, you do not get a natural log. You only get a natural log if it's x to the negative 1 power. In general, again, if you have x to the n power, and you're finding the most general antiderivative of that, it's x to the n plus 1 over n plus 1 plus c, but that only works if n is not negative 1. It certainly does not work when n is negative 1, because you'd be dividing by 0. When n is negative 1, you get this special fact, a very special and important fact. Things can look really complicated, like I emphasized last time, but actually be much easier than they look. Look, there's an example that looks pretty hard. Find a function whose derivative is 1 over square root of 1 minus x squared. If you didn't know, well, I remember the derivative of inverse sine is that function. Therefore, this answer is easy. But if you didn't know the derivative of that is that, you'd have no idea what to do here, right? If you didn't already know the derivative of inverse sine of x is this 1 over square root of 1 minus x squared, you'd have no idea what to do. Integration can be that hard. And even just slight changes in the problem can make you have no idea what to do. For example, if I change this function to an x over square root of 1 minus x squared, it's not clear what to do. Does the answer involve inverse sine? Not so clear. Is there a way to do this one? Yeah, there is. It's a little trick. I'm going to show you this trick. I'm not going to test you on this trick, but I'm going to show it to you. Wait till after I'm done, okay? I'm not going to test you on this trick. If you take Calc 2, you'll practice this trick a lot. It's called substitution. Let U be a new variable. Actually, our textbook calls it W, but I always learn U. Equal to, well, it turns out to be best to pick it to be what's under the square root here, 1 minus x squared. And try to rewrite this indefinite integral in terms of U. I guess that means that 1 minus x squared under that square root gets replaced with a U. Yes, it does. What else happens? How do you get rid of that x and change it to U? It doesn't equal U. Maybe you solve this equation for x in terms of U. That might be a good thing or an okay thing to try, but it turns out to be better to differentiate both sides of this equation with respect to U to get this. Then to pretend, here's a convenient fiction, to pretend this derivative is a fraction and pretend like you're multiplying both sides by dx to cancel it on the left. To get du is negative 2x dx. And boy, this x dx in there matches that x dx. Maybe I should divide both sides by negative 2 and get negative 1/2 du equals x dx. And maybe I should replace the x dx with negative 1/2 du. What in the world are we doing here? Yes, this should seem mysterious. That's okay. Make those replacements. All of a sudden, as long as this is all valid, it becomes an integral you can do, like magic. But you scratch your head and say, what in the world are we doing? Is this all okay? Hang with me. I just want to show you it works. This is now a power function with an exponent equal to negative 1/2. I need to add 1 to that exponent and divide by the same number. Negative 1/2 plus 1 is positive 1/2. Divide by that same number, positive 1/2, and then add c. These 1/2s completely cancel with each other, leaving no fractions. U to the 1/2 is square root of u. And maybe now I should plug in what u equals. Plug that in there. Maybe the answer is negative square root of 1 minus x squared plus c. Maybe. Maybe. Actually, I'm not guaranteeing I haven't made a mistake. How could you check this? By differentiation. Checking this is something you should be able to do on the test. Doing it like I'm doing, no, that's for calculus 2. But checking that this works by differentiation is something you should be able to do. Take the derivative with respect to x. Bring down that 1/2, keep the negative sign here. Oh, I'm using the chain rule, so I need an extra factor of negative 2x, right? I went fast there. That's the fastest I've ever done the chain rule before you. That is what I used. You should be practicing enough that you are now at the point where you say, yeah, I see what you did there. The negative signs cancel, the 2's cancel. This simplifies to x over square root of 1 minus x squared, the original function I was trying to integrate. Find an antiderivative of. I did it. It worked. I checked it by differentiation. You should be able to check proposed answers by differentiation. See, these match what I'm pointing at. Integration in the big scheme of things, I've heard many people say it, and I would agree based on my experience, probably is more important than differentiation. I mean, they're both important and they're related to each other, but integrals have more applications in the long run. Indefinite integrals, and then what we'll learn about in chapter 5, definite integrals have a lot of applications. And they're tied together. They're both called integrals for a reason. They must be related. Okay? Not saying this is easy. It's something I've got to practice. One more example. I did an example somewhat like this before. think with sine or cosine last time. Let me try this example. What's the integral of 1/7 e to the negative 4x? In other words, find the most general antiderivative of that, the most general function whose derivative is this function. I mean, we're doing a little guessing here, but there are good guesses and there are bad guesses. Bad guesses would be like cosine or sine or x squared. Those would be bad guesses. Answer's got to involve e to some power. And in fact, it's got to be e to the negative 4x power, because any other power can't, after differentiation, can't give me e to the negative 4x. But what goes in front? A 1/7? Negative 4/7? A little bit of experimentation reveals negative 1/28 works. Why? Because when I differentiate this, the chain rule gives an extra factor of negative 4. So to compensate for that, I had to take 1/7 and divide by negative 4. That's negative 1/28. Check it. Always check it. Take the derivative with respect to x. Chain rule. C differentiates to 0. Yeah, negative 4 times negative 1/28 is positive 1/7. We're done. You should be able to do guessing at this level on the exam. By the way, these are not gateway problems. Gateway is just derivatives. These type of problems show up on the Calc 2 gateway, and harder problems too.